Problem 2-27 says simplify each expression without using a calculator. Remember that to simplify expressions with radicals, you can remove perfect square factors such as in this example. All right, so remember this all comes from the rule if you have the square root of a product, AB, it's the same thing as doing the square root of A times the square root of b. As long as you're multiplying underneath the radical, you can split it apart. Take the square root of each of the factors and it'll give you the same thing. For instance there, if I said the square root of 9 times 4, which we know is 36, so the square root of 36 is the same thing as the square root of 9 times the square root of 4. And let's see, square root of 36 is 6, square root of 9 is 3, square root of 4 is 2, 3 times 2 gives us 6, and you know you're right. So this is just so you can see the kind of general rule. What you need to make sure is that you have your perfect squares memorized. I would memorize all the perfect squares from 1 to 25. So each number, and let's say for instance 1 squared is 1. So 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. That's all you really need to think about right now. That's just from 1 to 10, but as we look at the square root of 50, we're going to take it and we're going to break it apart here. 50 is the same thing as 25 times 2. 25 is a perfect square. That's why we're using it there. So this is the same thing as the square root of 25 times the square root of 2. Square root of 25 is 5. Square root of 2, well 2 is prime, so it's not going to break down anymore. It doesn't have any perfect square factors besides 1. So we end up with 5 radical 2. That is your answer for letter A. Let's look at B. We've got the square root of 72. Now as you look at it here, you could break this one down. There's several perfect squares that go into 72. 4 goes into it. 9 goes into it. We also have 36 goes into it. And since 36 is the biggest one, I'm going to go ahead and use it. So the square root of 72 is the same thing as the square root of the product 36 times 2. And that's the same thing then. If we take it and break it apart, we have the square root of 36 times the square root of 2. Square root of 36 is 6. Square root of 2 is 2. Or I'm sorry, is the square root of 2. So we have 6 times the square root of 2. Hopefully you start to see the pattern. If not, let's try another one. Let's do letter C. That's the square root of 45. So the square root of 45, well, as we look at it here, we want to ask ourselves, is there any perfect squares that go into 45? Well, your factors of 45 are, and if you're not sure, you can take it and do a prime factorization. 2 doesn't go into 45, but 3 does 15 times. That is prime. 15, though, breaks down into 3 and 5, which are both prime. But you see here, if we have 3 times 3, that's 9, so 9 times 5 should go into 45. So let's take that and let's break it into the square root of 9 times 5, which is the same thing as the square root of 9 times the square root of 5. Square root of 9 is 3, so we get 3 radical 5, or 3 times the square root of 5. And that is our answer for C. That is the last one there. So we'll continue to practice these more and more. But remember, the key here is to look for perfect square factors that go into the values that you're given under the radical. This is problem 2-27. If you have additional questions, make sure you ask your teacher. Otherwise, thanks for watching.